a body of mass m or a stone of mass m tied to a string, and the length of the string is r. It is fixed over here, and let's say some velocity has been given to this stone. As a result, this moves in a vertical circle. We are taking air resistance is equal to 0, and there is no other dissipative force, so that the energy is neither supplied to the system nor it has been taken away from the system. It is moving with a constant mechanical energy. Now we are interested, that is how we can apply the conservation of mechanical energy principle in this case for the various instances. Let's say if the velocity at the C point is given and r is given, is it possible to find the velocity at D point, E point, A point, H point? Is it possible? Yes, it is possible. And we can find it using the conservation of mechanical energy principle. Conservation of mechanical energy principle, it says if there are no dissipative forces like friction, air resistance, etc., then the sum of kinetic energy and potential energy of the system is constant. When we say mechanical energy is sum of potential energy and kinetic energy of the system. The potential energy, or to be more precise, the gravitational potential energy, what we're talking over here is mgh, where m is the mass of the body, g is accident due to gravity, and h is the height from the reference level. That is how high or below the body from the reference level is. If the reference level is this, body is above this level, then mgh, h is positive, this is going to be positive. If the body is at the reference level only, then the height from the reference level is 0, so mgh, that is, it's going to be 0. If this body is below this level, our reference level, then h is going to be negative and potential energy is going to be negative. Whereas kinetic energy is half mv square. It is square of v. V is over here, though we say velocity, but what we mean is it is the magnitude of velocity, that is speed. So half mv square is always going to be positive. So now conservation of mechanical energy principle, it says that is if there are no dissipative forces, there are no friction, etc., and neither the energy is being supplied to the system nor being taken out from the system, then it will have potential energy plus kinetic energy at the various instances, it is going to remain same. That is the sum of potential energy and kinetic energy of this mass which is revolving in a vertical circle, that is going to remain constant. Let's take any two arbitrary points on this circle and understand what do we mean by the conservation of mechanical energy principle and how to apply it. Now one thing in circular motion all the time is, the first thing where you have to understand is categorize whether this circular motion is uniform circular motion or non-uniform circular motion. Like in this case, this is a non-uniform circular motion because a mass is tied over here, string is here, and it's supposed it has some velocity. So while coming down, it's obviously it is losing on the height, it is losing the potential energy, its speed will be increasing. We have a common experience also. And over here, when it rises further, then certainly its speed will be reducing. It will reducing because it is gaining on height. The potential is increasing, so kinetic energy will be reducing. So over here it is least. Then after that, this is losing on the height. The speed will be increasing. It will gaining on the speed. So over here it is a maximum gain, and once again the losses of speed they will start. So this is a case of non-uniform circular motion, and you know that in non-uniform circular motion we are going to have a centripetal acceleration. Centripetal acceleration, you know, that is whenever there is circular motion, centripetal acceleration will always be there. Whereas the tangential acceleration, which arises because of change in speed of the body which is revolving in circle, and in this case there is a change of speed. The speed is changing. Vc is not equal to Vd, is not equal to V. All the speeds, they are different in a vertical circle. So when all the speeds they are changing, so this is non-uniform circular motion. So as we have done earlier, when the speed is changing, there has to be a tangential force also, there has to be a tangential acceleration also. But right now we are interested in using the conservation of mechanical energy principle. So we have taken 2 points, A and D. A and D, they are 2 points, and we are going to use this conservation of mechanical energy principle. So if we are applying conservation of mechanical energy between these 2 points A and D, then mechanical energy at point A is equal to mechanical energy at point D. But what is mechanical energy? It is mgh plus half mv square. So we can say potential energy at A plus kinetic energy at A is equal to potential energy at D plus kinetic energy at D. This is what this means. So potential energy at A, let's take it as H1 from here to here, we have taken, or let's call it as HA. So potential energy A is mg HA. HA you can easily find, we have just done that. Mg HA plus half m VA square is equal to potential energy D. This is mg 0 over here, H is 0, but otherwise if we had taken this, then H would have been like this, plus half m VD square. If we take E also into consideration, then this should also be equal to MED, mechanical energy at D, is equal to mechanical energy at E also. So if we take into consideration point E also, then we add MEE also. So it is mg, let's call it as HE. So mg HE plus half m VE square. Let's understand this by taking an example. So now over here we have this stone or a point mass body of 2 kg mass tied to a string which is of 3 meter length. This is fixed over here. As a result, this can move in a vertical semicircle. This can oscillate over here. It has been released from its horizontal position, that is the velocity over here which has been given is 0. We are asked what is the speed or velocity at the point B. So what we do is we take this bottommost level as our reference level. So we have taken it as reference level. So what we say is, because there is no dissipation of energy, energy is not wasted against air resistance, etc. So we can use the conservation of mechanical energy principle. It says that is mechanical energy at A is equal to mechanical energy at point B. It means potential energy at A plus kinetic energy at A, mechanical energy at B means what? Potential energy at B plus kinetic energy at B. What is potential energy at A? That is mg. M is what? That is mg HA plus kinetic energy is half m VA square is equal to mg height of B plus half m VB square. That is what it means. That is mg H this level plus kinetic energy, mg H of this plus kinetic energy over here. We have taken over here, that is suppose the speed or velocity is VB. So what is HA from here to here? That is equal to 3 meter only, because the length of the string is not changing. So this is 3 meter. So from here to here is also 3 meter. So M is what? M is 2, G take it as G, H is 3 plus half M, speed given, velocity given over here is 0, mg, this is at the reference level only, so it is 0 plus half m VB square. M is given as 2, so let's write it as 2, otherwise it doesn't matter, it will get cancelled otherwise also. So it says 2g3 is equal to half 2 VB square. So VB comes out to be 2g3 under root. If in this equation we don't write the value of mass, we simply write it as m only. So over here also it comes out to be m. mg0, this 0 only. So this is also 0. So equation comes out to be this is equal to this. That is, it says mg3 is equal to half m VB square. M and m they get cancelled. And VB comes out to be 2g3. That is whether this is of 2 kg body, 3 kg mass body or 10 kg mass body, any mass. This is the velocity over here is independent of this mass. The velocity will remain same. Let's say now we have to find what is the speed at the point C when this string is making angle 30 degree with this horizontal position. We are supposed to find what is the value of Vc. So obviously as earlier, we can use mechanical energy at A is equal to mechanical energy at C. It means potential energy at A plus kinetic energy at A is equal to potential energy at C plus kinetic energy at C. This is what we have to find out. This is what does mean. Potential at A is mg, this is 3 plus kinetic energy is 0 because speed is equal to 0 over here, and over here this is mg. We are supposed to find this height we have to find out. So let's call it as h, mgh plus half m vc square. Now as done earlier, if this is from here to here is length of the string 3 meter, and if we make this triangle, so if this is 3, so from here to here this is right angle triangle, so this is going to be 3 cos theta and this is going to be 3 sin theta, that is 3 sin 30 degree. If this is 3 sin 30 degree, it means from here to here this is also 3 sin 30 degree, and sin 30 degree you know it is half, so this is 3 sin 30. From here to here this is 3 meter, so this is going to be from here to here, that is what you say h from here to here, h from here to here is 3 minus 3 sin 30 is equal to 3 minus 3 into 1 by 2, that is because sin 30 degree is half, so 3 minus 3 by 2 is 3 by 2, that is 1.5 meter. So we know the value of h, and now we can simply put the value of h as 1.5 meter over here and we can get the answer. So it is mg3 is equal to mg 3 by 2 plus half m vc square. Once again m can be taken out and can be cancelled. So now you can solve it. You can take the value of g as 9.8 or 10 and you can eventually find the value of vc.